Oh, hello everyone. So we know you all can't wait to go for lunch already, so we will make this as quick and painless as possible. Sven and I are here today to introduce our project, the Mobile Security Testing Guide. The goal of our project is to write a comprehensive testing guide for mobile security. And our main product output is a security book, the OWASP Mobile Testing Guide, which is right now about 50% complete. We also have a few other things, including the Mobile AppSec Verification Standard, MESVS, and the Mobile AppSec Checklist. The MESVS is already quite mature, so it can already be used. It's in version 0.9. The testing guide will still take us probably until the end of the year. And one reason we are here today is to gather more support, get more contributors, and get some people, talented people to help us with that. So we started with this project about a year ago, and when we started working on the guide, we discovered that we actually were not completely sure what you were supposed to test for in mobile security testing, because there was no industry-wide accepted best practice for that. So we took a step back in the beginning and looked at what the actual security requirements are for mobile applications and how we can formalize them into a set of requirements that fit different types of mobile apps. You maybe know the ASVS, the OWASP Application Security Verification Standard, which also exists for a few years already. This also has a small section about mobile apps, but it's by far not comprehensive enough to cover everything we need. And it's mainly focused on web applications. So we forked this project and made our own version of that. The MESVS covers mobile application security on a very high level and is not operation system specific. So it can be applied to Android, iOS, Windows Mobile, or whatever you want. And when we were discussing what the requirements are, there actually were a lot of questions that were not so easy to solve. One good example is end-to-end encryption. And we actually discussed this quite a lot on GitHub and Slack. And there are many different opinions if it's useful or not. So end-to-end encryption means that you layer a type of encryption on top of what you already have on the transport layer, like TLS. And the apparent benefit of this is that you get an additional layer of security. So if TLS breaks for some reason, for example, if a CA is compromised or there's a bug in a standard library, you have another layer of encryption that still protects the data. And it doesn't sound that bad, but the problem is that it introduces a lot of complexity, and it's often not a very good idea to tell developers to implement their own crypto. And if you have seen this, what comes out of this in practice a few times, then you know it's just the benefit of doing this is very small compared to the effort and compared to the possibility that you just mess things up completely. So the design philosophy that we followed in general was to cut away everything that doesn't have a lot of benefit and is complex and really reduce it to the basics that you need. And we ended up with 43 security requirements. I think at some point we had a total of 80 or so, and we cut a lot of that away again. So we have 43 basic requirements, 19 defense in-depth measures that you can apply, but that are not 100% required, more flexible. And we also have anti-reversing controls. And we have grouped these three types of controls into layers. So L1 contains all the security best practices that are applicable to all mobile apps. For example, everybody would agree that you should never dump plain text passwords into application logs. And you should never send passwords in plain text over the network, things like that. So this basically can be applied to every app. Then level 2 contains defense in-depth controls that may be necessary if you have apps that have highly sensitive functionality or handle sensitive data, such as online banking. And then you want to introduce things like 2FA, step-up authentication, maybe SSL pinning, and things that are a little bit more effort, but that are recommended in that case. And MESVSR covers tamper-proofing and client-side protections, and this is completely optional, and we recommend only using this in very particular cases. So maybe if you just watched Slavomir and Wojtek's talk before, this came up as well. So what can you do to detect root, to protect against code injection, frameworks like Exposed and so on. Just an example how this looks like. So this is a group of requirements discusses network communication. And you can see that the level 1 are pretty much common sense things. You should encrypt data on the network. You should use proven protocols like TLS in a proven configuration. That's commonly accepted to be best practice, and we have that. And you should verify the certificate of the server, which is very easy to do, and most APIs that you would use for HTTPS connections do it automatically anyway. But when it comes to SSL pinning or implementing things like a custom CA store, then this is not something that you always have to do. So if you have a very simple app that just, I don't know, allows the user to display some basic information, then this is not necessary. But for a banking app or an app that handles financial transactions, this is definitely recommended to do. So even though we created the MESVS as a basis for the testing guide, it can also be used to define security requirements early in the security development lifecycle. We have actually done this with a few customers, and this works very well. It's very rewarding. Developers actually start to like you and take your input and advice. Yeah, and this is actually the best way to use it. So if you have the requirements defined early on and you code according to these requirements, then you can avoid a lot of pain later on. So a lot of you have probably tested web apps or mobile apps that haven't had security in the SDLC and that are completely broken. And that causes a lot of pain because the pen test is done at the after UAT sign up, and you don't expect to find anything, but then you discover that the app is completely broken, and then everybody panics and people struggle to fix the issues as quickly as possible. And this can be avoided. Another way to use the MESVS together with the testing guide and checklist is in traditional mobile app penetration tests. And for this I will give to Sven.
Okay, so let's continue with the mobile security testing guide. So what is actually the mobile security testing guide? It's not just a guide to spot the obvious mistakes as in this picture here. It's a comprehensive guide that should support a tester during the whole testing process. So it maps directly to the MESVS requirements that were just explained by Ben. And we are focusing for now on iOS and Android native applications. Hybrid applications or mobile application development frameworks like Apache Cordova, Kony, or PhoneGap or things like that are not covered yet. If someone of you or someone else has experience in that, we would be more than happy to get more contributions in that area too, to also cover these kind of things. The goal is to ensure completeness of mobile app security testing through a consistent testing methodology. So security testing methodologies, at least the ones that are publicly available nowadays, have not really caught up with the changing development that we need to test more and more mobile applications. So don't get me wrong, there are of course a lot of fantastic resources out there, like the Mobile Application Hackers Handbook, the iOS or Android testing guide from the InfoSec Institute, but we do not have anything at the moment with the maturity of an OWASP web application testing guide just for the mobile world. And we're missing some industry acceptance for a methodology that everybody is agreeing on. For security checks of the endpoint, we are referring, you should just use the OWASP web testing guide. So we do not want to create redundant content in the MSTG. Therefore, the MSTG is more client-focused here. So how does the document structure look like? So the MSTG explains basic security testing processes and techniques, and these are the foundation of all the test cases. So this starts from how is actually static analysis be applied to your mobile apps, how you can do it when you have the source code, how can you do it if you do not have the source code by decompiling the app, how to execute dynamic analysis. And we also want to clarify that some vulnerabilities that we all know from web application penetration testing are not really applicable sometimes to the mobile world. So as an example, cross-site request forgery is a big thing in web applications and can become quite severe, but to the mobile app, to mobile apps and native applications, it's not really applicable. Same for cross-site scripting. Cross-site scripting can become an issue if it's a stored cross-site scripting in the endpoint that is then sent to the app, but something like a reflected cross-site scripting is also not really something. So there are limitations also for cross-site scripting. To be able to test something, you need to understand the basics and the concepts behind it. So the platform overview, explains the architecture and security mechanisms that are available in Android and also in iOS. So this makes a deep dive into the different OS-specific concepts like app sandboxing, how inter-process communication is working on Android, how does an APK actually look like when you unzip it, how does it look like when you decompile it, where is the data directory when I install an IPA or an APK. So this gives you an overview about that. Then we have the security testing basics that are then referring to the different, to iOS and to Android. So here we explain how to set up the test environment. For example, if you're testing remotely with your own devices, with your own jailbroken or rooted devices, then everything is quite straightforward. But what is actually happening if you need to test on-site at client premises? Sometimes you might not be allowed to use a jailbroken device because this might already violate the company policy. Or maybe you need to use the hardware provided by the client, which is not jailbroken or rooted. Or even worse, maybe you need to use an emulator and then you have another restrictions. So this also tries to give the tester some guidance so that you can articulate also different limitations that you might be facing to the client so that everybody is on the same page. The test cases are then the most interesting part of the MSTG because they are really describing in detail how a tester can verify the MASVS requirements. So let me quickly show you. Okay. Whoop. Okay. So here, so the MSTG, the Mobile Security Testing Guide, is all hosted in GitHub. So we're doing everything in Markdown, and we chained it together with Git books. And because we chained this together, we already have a readable book online available here. So on the left side, you can see the table of contents. As I was just explaining, we have the testing processes and techniques. And then we have split it into an Android testing guide and the iOS testing guide. So both have the same structure. It's just that they will be covering then the different operating systems there. So you have the platform overview, the Android security testing basics, and then we have testing data storage, data cryptography, and so on, which are all mapping to the areas of the MASVS. So to give you a quick example, in the Android testing guide, testing data storage, there's one test case, for example, that is called testing for sensitive data and logs. So all test cases have the same structure. First, there's a quick overview that is just explaining the basics of this finding and what kind of risks there might be if you have such vulnerabilities in your app. Then we have the static analysis part. It just wants to give some quick guidance on what kind of keywords you should look for while you're crawling the code. So in this case, for example, Android util-log, which is the standard log mechanism in Android, but you maybe should also look for system out print or system error print in case developers would be using these kind of things and not standard log mechanisms. Then dynamic analysis part. In this case, ideally, you want to have all the output that is generated while you're starting, running, and closing the app. So you can have a look at that with Logcut, which is a tool already built within Android Studio. So when your app is debuggable, you can see all the log output coming, then you can filter, and then you can see what's actually going on while you're running the app. You can also use it on the command line and pipe everything into a text file and then investigate later on. So once you identified some finding, we have a section called remediation to give the tester something in their hands that they can propose to the developer to remediate those findings. So in this case, one solution would be to use ProGuard and just strip out Android util log, and then all the log files would be cleared or would be gone in the production build. We also have references, so we're mapping to the OWASP mobile top 10. Of course, we are linking back to the MASVS, CWE, and also some tools that you might want to use while verifying this test case. Let me give you just an overview of the key topics of the MSTG. So, as we are all carrying around our mobile phones, we actually carry around a lot of sensitive information. So if this one gets stolen or you lose it, then a lot of sensitive information might be exposed. So the first rule is, of course, sensitive information shouldn't ideally be stored on the mobile device. If you need to store it, then use something secure as the keychain on iOS or the key store on Android. For testing the local storage, this can become a big playground for a tester because there are simply so many different there are just so many different ways on how you can store data. You can store it via XML files and shared preferences on Android orplists. You can use SQLite databases. You can just store it in plain text files. And you can also use the external storage on Android. So, so there are a lot of different areas, and all of these mechanisms need to be understood by the tester so that he can investigate on them. Another question is, if you're storing data, is cryptography used? Is maybe just some simple bit shifting used that where the developer was thinking this might be a sufficient protection, or is there really a strong mechanism used for storing the data? If you have sensitive data in your data directory of the app, then it's also available in your backup, then it's maybe synced to the cloud. So all of these kind of things need to be looked at. What about data in the memory? What about data, or what about auto-generated screenshots while you're backgrounding the app? So there's really a lot of things that are stored on your mobile device, and the MSTG tries to give you a structure in those areas of where a tester should look for, or should look for data. Platform interaction is another key part for mobile testing. For testing the apps, one thing you should look for is app permissions. So can your apps read all your SMS, or can they, or do they have access to your microphone and are therefore able to record audio? What about inter-process communication? If one app is exporting a function or a content provider that might be queried by other apps to get data, is this really needed? If so, are there any permissions? So this is also a big topic that need to be verified. Also, the implementation of web views. If you're using web views in your mobile app to render some pages, the web views should be hardened, meaning the file protocol handler is available in a web view, which would give you access to the local file system. If you do not need it, disable it. If you're just rendering a static page, disable JavaScript, so to really reduce the attack surface as much as possible. With mobile devices, also local authentication was introduced, like Touch ID, which is the most famous one, I would say. This is already actively used, and maybe sometimes just by pressing your thumb on your mobile phone, you can already grant payments or make a sneak peek to your bank account balance. But there are also different kind of implementations for Touch ID. There are actually two different implementations, and you need to check if the implementation is actually covering your threat model or the threats that you are faced with. A lot of code is obviously running on your mobile device, so you also need to check the code quality and the build settings. So verify security features, verify if all the security features are activated. You can already do some things with ProGuard when you're using Android NDK or iOS. You should verify that all the compiler settings were used correctly. What about third-party libraries? Are all the debugging symbols stripped out? Is the library that you're using maybe outdated? Because nobody wants to reinvent the wheel. A lot of developers are, of course, using a lot of libraries. Same for debugging code, verbose error logging, and exception handling. All of these things need also to be checked on the client side. So how is the MSDG organized? As I was already sharing with you, everything is in GitHub, meaning everything is in Markdown, and this is still a work in progress at the moment. As I was also already showing you, we also have a Git book available, so you can already read everything online. And we also have some bash script where you can make out of the Markdown also a Word document. Then we continue with reverse engineering.
All right, so the problem. So you maybe noticed that in the last few years, a lot of apps like financial apps, online games and so on, started to use a lot of obfuscation and anti-tampering, anti-debugging and so on. And security testers traditionally don't test that kind of stuff, so they don't really have a good way of dealing with it. And we see this a lot of times. For example, what we see sometimes in report are things like lack of obfuscation being reported. And this is, for the client, something like this is completely useless, because what are they supposed to do? Obfuscation is just an umbrella term. It can mean a lot of things. It can mean just turning on minify enabled is true in the progress settings. It can mean applying really complex control flow obfuscation, using white box crypto, using virtualization. There's a lot of stuff you can do, and it really scales. So what we thought would be a good idea to have a proper assessment methodology and proper recommendations in this field as well. And something like this doesn't exist at all in the industry. And it's also kind of controversial. So there are many strong opinions on obfuscation. Many people say it's completely useless. Some say it's okay to use it in some situations. And we think we should be pragmatic and look at cases where obfuscation can be useful and define those, and also have a way of verifying if everything has been done correctly. So the skills needed for assessing anti-reversing protections are traditionally what you would find with a malware analyst, for example, because malware has been using this kind of thing since the 80s. And a lot of ideas and tricks actually come from the malware world. This is exactly the same things that you find now in banking apps. So the first useful skill to have is to be able to determine whether the obfuscation and software protection used is actually used in the right way. And you always have to be aware that every software protection scheme can be reversed and can be broken eventually. It's just a matter of the effort you put into it. So we all know that. So you should never use it as a replacement for proper security. You still need to do all of the SVS level 1 and have all the security controls in place. And then you can think about using obfuscation and anti-tampering for certain tasks. For example, let's say you want to protect your source code from simple reverse engineering, or you want to do DRM, you want to prevent cheating in a game, you want to prevent code injection. We heard about root malware that's very prevalent now, and things like that can be, to a certain degree, defended against with software protection. So in terms of content, the Android reversing guide is already quite far ahead. So we have a complete basic reverse engineering guide that explains static and dynamic analysis. We tried to do everything using free tools. So we built an environment using just standard SDK, IntelliJ, and free stuff. But we also mentioned some commercial tools, because in the reverse engineering world, there are some tools that are just so common that you cannot do without them. Example, IDA Pro, so everybody uses it. And if you want to get serious about reverse engineering, you probably have to buy a license for that. But other than that, everything can be done in theory using free tools. We cover static analysis, debugging, tracing, things that you can do. Normally, we also cover frameworks like Exposed, Frida, Script, Substrate, CEOS, everything modders and hackers use. We have how-tos and tutorials for them, runtime instrumentation, patching, etc. And beyond that, we also cover a lot of advanced topics using Radar 2 and frameworks like Anger, doing symbolic execution, writing custom disassembly scripts that use frameworks and so on. So it's pretty cool. And we also have chapters that cover anti-reversing defenses in particular, including root detection, anti-debugging. And in these fields, we've also done quite a bit of original research. So we're describing some anti-debugging stuff and integrity monitoring mechanisms that you won't find anywhere else so far. So we have some methods of reader detection, for example, messing around with debugging structures in memory to manipulate function pointers so that the debugger just disconnects. It's pretty fun stuff. But on the other hand, we also show how to bypass it. Which, you know, it's just a cat of mouse game, so people will always come up with new ideas and there will always be a way to bypass. It's just a matter of how you do it. And finally, we also have practical challenges where you can practice what you learned. And you can find these challenges on our GitHub repo. Under CrackMe's, so you just go to the main page, CrackMe's, and at the moment we have 6 levels. I hope that it will be more soon. And they also have already solutions that people have contributed, so you can see how to solve this challenge in different ways. Level 1 is pretty easy, so you just use Frida or JD or whatever. But with level 3, you can see it doesn't have a solution yet, so it's already getting pretty tough. And we also have an uncrackable app post-cracking survey where we try to find out how much difficulty people actually had with solving the challenges, how much hours they had to put in, because it's interesting for us in terms of finding metrics and effectiveness assessment methods, because nobody really knows how effective this stuff really is, right? If somebody with a lot of experience might be able to solve a challenge that we think is difficult in 10 minutes because he has the right tools. So this is something we try to start to get a feeling for. Okay. And there's a bit more that is to that, so we're also working on metrics for assessing obfuscation effectiveness. So there's a lot of research papers dealing with the topic, but like I said, it's controversial, and so far there's no metric that is simple to use and reliable. But we have forked a separate sub-project just to gather ideas and find some ways of doing this. Maybe it's impossible, we're not 100% sure yet, but I hope it will be successful. And yeah, the assessment methodology, so we're working for a methodology testers can use. We call it a resiliency assessment. And the goal of this assessment is to find out for a given set of defenses or protection scheme, if it fulfills its purpose, if it's effective, how much you can expect that it delays adversaries in some form. And of course, we still need help with that. So we actually don't have a lot of contributors at the moment for the reverse engineering stuff. So if any experts on obfuscation or cracking, malware analysis in the audience, we're very happy to get some help on that.
Okay, so let's quickly recap on what we have heard so far. So we have the MASVS, which gives us high-level requirements for mobile application security. We have the MSTG that is outlining those requirements into technical details. What was missing somehow is that we needed something for a tester that he can document something, and we actually can give it a tester, sorry, not developer. So in order to start with the testing. The first thing you need to do is the preparation part, which is really the most important part here. So first of all, you should sit down, ideally with the developers, maybe also some IT security folks from the enterprise, because for most of the people, it's not sure what requirements are actually applicable for them, because nobody told them. So according to the MESVS, those requirements that are level 1 should be or are applicable to mobile apps. But those with level 2, you actually should sit down with the developers and the IT security folks from the enterprise, ideally, so that you can find a solution and maybe proper to find proper solutions, what you can propose, maybe also company-wide. Because do we really need root detection? Do we really need SSL pinning? These kind of things should be at the beginning of a project a requirement for the developers, if they should implement it or not. And if everybody agrees on that, afterwards, this is the baseline also for the tester, because otherwise he might put stuff into the report that will anyway never be implemented, because either they might accept the risk or they just have no budget for these kind of controls, or the risk is simply not there. So we were already using that in the past with our clients, and the response was quite happily, because they got these document with requirements and they actually have something that they can work with. And there was a lot of positive feedback about this, and they can actually use it then internally to create, for example, their own mobile policies on what kind of things should be implemented and what not, because there's a big lack of this at the moment. I mean, all companies are quite mature when it comes to network security. Web application security is also picking up, but when it comes to mobile security, actually nobody's giving them the correct requirements at the beginning for a project. So once you have your baseline on what requirements are actually applicable, you can actually then start with the mobile app security testing and walk through the applicable requirements one by one. So let me just quickly show you the sheet. So we have the security requirements for Android and for iOS. This is now the sheet for Android, and you can see here the MESVS requirements, if they are level 1 or level 2. And then if they are either passed, meaning this requirement was applicable and it is implemented according to best practices, or if it fails, or if it's simply not applicable. Then we have here the linkage from the requirement to the actual test case. So if you click then on this, you will go directly into the guide, and then you know what to do as a tester. Same for the resiliency against reverse engineering requirements. And this Excel document can actually then also be used as some kind of reporting. So we have a dashboard where you can put in all of your meta information and a nice management summary with a spider chart. So you have a table here that summarizes now everything, which of the findings were applicable, which were not applicable, which one did pass, which one did fail. And you can see a visualization of that here for Android and for iOS. And you can see how compliant you are against the MESVS. So this might be also very useful if you do this with several apps in a company. Then maybe you see that often in authentication and session management, you have a big gap here. So that might be a thing where you should put your efforts in order to resolve it. And ideally, you should see those charts then growing over time, then more and more requirements are built in. So at the moment, we have 32 contributors in our GitHub repo, so thank you for that. The help is really appreciated, and we already have a really good document at the moment, but there's still a long way to go for the rest of it, especially for iOS. So how to get started to contribute. So we have a README file in our GitHub that will give you some guidance in the beginning. Everything is coordinated in Slack, so we are in the OWASP Slack channel. And we also have a project dashboard, meaning we have a GitHub project created, and all the missing content is now an issue so that we can easily track it and assign it to people. So if you're interested, you're more than welcome to support us here. And maybe one last thing. And there will also be a mobile security workshop at the OWASP Summit. So in case anybody's interested or is anyway at the OWASP Summit, please feel free to contact us so that we can coordinate maybe the work on the MSTG for this. Okay, that's it. Thanks. So for the MESVS, we already have now a pre-release. So this was already in January, and there are still some minor changes, but this is already pre-released because this was also one of the challenges during the whole project. Because in the MESVS we had too many changes, but we were already still working on the MSTG. So the strategy was to first make a release of the MESVS and then really work with that as a basis for the MSTG. So we hope that maybe in Q3 we have a draft, and hopefully at the end of the year, final version, and hopefully next year we can also make a printable book that would also be one of the goals.
Very good question. Like I said, it can be useful as part of a tampering detection strategy in some situations. And we actually do recommend in level 2, for example, for financial apps, that you should have kind of a soft root detection where you detect if the user themselves root the device, and you at least give the user a warning and tell him that this is a dangerous thing. So nothing where you just quit the app, but at least create some awareness. But if you want to apply an anti-tampering scheme, then root detection should be part of it as well, of course. So you will have different mechanisms for root detection, and we actually cover a lot of those in the guide as well. So if you go to the chapter testing anti-tampering, so the first point will be root detection, and here we list all the common root detection methods, including safety net, detecting packages, typical package files that belong to routing tools, detecting binaries, checking whether SU is in path, doing stuff in native code, for example. So you should, you can combine all these things and like spread them out through the app at different places and make it a bit more annoying for someone to analyze the app, you know. But in the end, it can be bypassed, of course. We also describe some really powerful bypass technique, including compiling your own kernel models to hook system calls. And with this, it's very difficult to really have effective root detection, because if the kernel is compromised, then you have not really any information that you can trust, right? But yes, it can be useful in some situations.
Thank you for your sample.